Hi everyone, so we're moving on to 8.3, which is going to be Charles' Law, which is going to relate temperature and volume as long as we keep the pressure and the number of moles of gas constant, right? So the question that I want to go over is the one asking about a balloon, right? So it says a balloon has a volume of 785 milliliters, so that's my volume 1. It's at a temperature of 21 degrees Celsius, so that's my condition 1. Both get the subscript 1. It says, what is the new volume of the balloon at constant, I skipped a step. If the temperature of the balloon drops to 0, so T2 is 0 degrees Celsius. That's my second condition, right? So I've gone from this situation to now dropping the temperature. And it's asking me, what is the new volume of the balloon at this new cooler temperature, right? So the way I want to attack this problem, so I'm going to give you two different ways. When I did Boyle's Law, we did numbers first and then rearranged and did the math. Here I want to give you another strategy where instead of before we adding numbers, let's rearrange the equation to just solve for what I want, which is V2, and then we'll add in the numbers. So there's Charles' Law. So what I can do if I'm solving for V2, if I multiply both sides by T2, all right, I'll do it out explicitly. Separate my work from my organized information. What I see here is T2 and T2 cancel, right? So what I can write now is I see it's T2 times V1 divided by T1 now has the variable that I want, T2. So now all I have to do is plug in my numbers. T2 is 0 degrees Celsius. V1 is 785 milliliters. Divided by T1, which is 21 degrees Celsius. And immediately what you're going off in your head right now, something's wrong. If I multiply 0 by this number and then divide by that number, I'll still get 0, and that doesn't make sense. A volume of 0, when I know I have something, you can't do that, right? Only fundamental particles, as far as we know, don't have volume. So gas does, so we need to figure out what we did wrong. Well, what we realized is that when we're using the gas law equations, everything has to be in Kelvin. So the way we do that, right, if we remember all the way back to either chapter 2, I believe it was, so we'll do a little side work. When we're converting between solving for Kelvin, we take the amount we were in Celsius and then add the number 273.15. And hopefully that didn't go off the screen. Okay, good, we're good. So if I want Kelvin for 0 degrees Celsius, well, I add 273 to it. So let's substitute that in. 273.15 Kelvin, 21. If I can add that to 273.15, right, I'm going to end up with 294.15 Kelvin. Now I can go through and do the work, right? My units of Kelvin will cancel. I'll be left with units of mils, which is what I want. Those are units for volume. So let me get rid of that a little bit. If we go through, do out my math, dump that into the calculator, we should get 729 milliliters as my final answer. Does that make sense? That's a question you should always ask yourself when you're done doing any kind of calculations. I started at 785. It reduced it down to 729, and that makes sense because maybe you've seen it before. If you take a blown up balloon and put it in an ice water bath, it actually will contract. And that's exactly what we see. We have contraction because we cooled it from roughly room temperature at 21 down to 0, which is freezing. So that was Charles' Law.